Hi, I'm Welder Oliveira, and today we are talking about tangent plane. So let's start. Let's compute the tangent plane for this function here, passing from the point x equal 1. So let me write here. Passing from to the point x0, y0 equals to 1, 1. As in the picture here. So here you have the point 1, 1, and you have a point in the surface of this function here, and we want to know what is the equation of this orange plane here, which is a tangent plane in this surface here, passing to this point. So let's do that. If you want to know how to draw this kind of to sketch this kind of function, I have a video for that. You can check how to sketch a two variable function in my channel. So let's start. First of all, we need to know what is the equation for the plane. The equation is z minus z0, where z0 is this value for z here, okay, equal to the f of x, okay, in the point x0, y0 times x minus x0. It's very similar to the equation till now, to the equation of a line, a tangent line passing from a point, okay? So plus, we need here to put also the plus f, the derivative of f relating to y in the point x0, y0, the point of tangents, times y minus y0. Let me just resize this here, this entire expression here. So here it is. Let me move all of these here from the left here. So okay, now it's okay. So we need to compute every single part of this expression. Let's see what we have. We already have x0 here, which is 1. We have y0, which is also 1, but we don't have z0 till now. So first of all, let's compute z0. z0 is equals to, using here the formula for it, because remember, f of xy is just z, okay? So when we plug x0 and y0 here in the formula, we get 1 square plus 1 square, which is 1 plus 1, 2. So z0 is 2, okay? So let's move on. First, another ingredient that we need here is the derivative of f relating to x, and also the derivative of f relating to y. Let's compute it. So the derivative of f relating to x is equal to, so we take a look on this expression. The derivative of x squared is just 2x. The derivative of y squared related to x is just 0, because it does not depend on 0. So it's done. The derivative of x on any point xy will be just 2x, okay? And the derivative of x, let me put it here in the front, f of y will be related to y, x squared the x squared does not depend on y, so this here will be constant related to y, so the derivative of a square related to y will be 0, and the derivative of y squared will be 2y related to y. So let me resize all of this here in order, let me try to resize it again. Okay, so I use this space here to finalize our question. So we have now z0, we have f, the derivative of f related to x, derivative of f related to y. So the equation of the tangent plane will be z minus z0, which is 2, equals to f of x, in the point that's important, f of x computed in x0, y0. So when x0 is 1, that will be 2 times 1, which is 2. This here is 2. Can you see it? Let me just do this here. F of x in the point x0, which is 1, and the point y0, which is 1 as well. This is 2 times the x, but the x is 1, so 2 times 1, which is 2. Okay, so let's put it here, times x minus x0, which is 1, plus f of y. Okay, f of y is 2y, but we are computed it in the x0, y0 vector. So instead of x and y, we will put 1 and 1. The x does not matter because this here just depends on x, so will be 2 times y0, which is 1. So 2 times y minus y0, which is 1. So here it is. Let's finalize this expression. Let me resize all of this here. Just excuse me just a moment here to resize this expression here. Okay, let me move it up. Can you see the answer? Well, let's do it. Let's isolate z here. Z is equal to this here I will pass to the other side, so keep that in mind. 2 times x is just 2x. 2 times y is just 2y. 2 times minus 1 is minus 2. 2 times minus 1 is minus 2 again. And as I pass this for the other side, it will be here plus 2, cancels out with this. The entire constant here on the right side will remain as being just minus 2, negative 2. And so this here is already the equation of the plane, okay? And if you prefer, you can put 2 on evidence, but that's not required. So let me highlight this here. This is the final answer, the answer for this question. So let me just highlight it here. This is the equation of the tangent plane which pass through the point x equals to 1, y equals to 1, and z equals to 2. Pass to this through this point here, and is tangent through this point here to this function, to this 2-variable function. So this is the video that I have planned for you today. Hope you see you on the next video, or on online classes. Okay, if you intend to take a class with me, I will give you information on the description of this video. See you next time.